we start. You'll probably hear some noisy sounds. That's my computer still running some simulations, so I can't do anything about it today. Hello again and welcome to the module 5. This is the last session of this course. For those who don't know me, I'm Ivan Bricida. I work for 10 years as a business intelligence analyst at Google. I have a computer science and finance and data analysis degrees, and I founded a project pythoninvest.com 3 years ago. And this course is the first time I run it and try to show all the experience that I got doing many stock analysis in the past 3 years. I apply my knowledge as a retail investor for daily trading strategies. The agenda for today is as following. We'll start from the questions asked on Slido, and I'll share some comments from home assignment number 4. Then we'll proceed to the system design view and discuss the last step, step number 5 of the system that we are trying to build. But before that, we'll talk about advanced simulation. Last module, we covered basic simulation. And this time we'll go in more details for precise and advanced simulation with more features. And finally, we'll finish our module today with automation session. So I'll show you how to create a Python project in Visual Studio Code environment, how to move code from the several notebooks that we covered during the lectures into the Python scripts, and how to create a one data workflow that you can run locally from a Python file or from the interactive environment Jupyter notebook on your local computer and not on Google Colab. And finally, we'll touch Capstone project requirements. I didn't see many questions from you, so I assume that mostly those requirements are clear, but if not, please ask more questions. So let's begin. Module 5 is the final step of building our automated strategy of trading. We started from module 1, where we collected data from various data sources. Then we proceeded to module 2, where we created one single data frame. During module 3, we experimented with several models and found the best performing model, which is a random forest. And at the module 4, we created a trading strategy and tried to do the simulation. And today we combine all of the previous steps together so that you can run it with from a terminal or a command line with one simple click. As usual, please ask questions at slido.com. I don't see many questions from you recently on this source. Hopefully everything is very clear now. Homework number 4. Let's compare the stats that I received from your submissions. We started from homework number 1 and there were about 200 submissions, and 124 submissions showed the time spent for that homework that it was between 2.5 and 6 hours. Homework number 2 was twice less submissions, 95 submissions, and it was between 5 and 12 hours for homework. Homework number 3 was 60 submissions, and on average it was between 4 and 12 hours. And last homework had only 31 submissions, but the complexity was not that hard. So the time spent was between 3 and 6 hours. Probably we see such a steep decline of submissions because all homeworks are connected, and it is quite difficult to submit homework number 3 and not submit homework number 1. But let's discuss the core ideas behind homework number 4. So this homework did not require from you a lot of coding, but the main purpose was to try smaller adjustments for the whole system and see how you can improve or not the final financial result. So question number 1 was to find the new global best average growth rate of a capital with random forest tuning. Before that, we used a decision tree. Random forest is a more advanced model, so I asked to apply the same code approach with defining different thresholds and find the new best solution of the whole system. And if you were right in submitting your answers, you should see that the best average capital growth was 13.64% per year. That is in 4 years of test simulation, it is more than 50% growth. So next task was to reduce the total number of features. And in that particular task, I asked to reduce the number of dummy features because it had some previous test dummy features which are not very useful for the final model estimation. You should see different results with this small adjustment of input data set, but you should be able to run the whole system again with run all commands for the Colab workflow. So for the question number 2, you should have copied the original home assignment for workbook and change the line of code where you define dummy variables and use the reduced set of dummy variables. Question number 3 has a different idea that you can leave the set of input features the same, but you can slightly change the variable that you want to predict. And in this case, we wanted to predict strong growth events, and by saying strong growth, I mean growth of more than 2% in 1 week, which is a big growth if you think about it. And the idea is that you might have less noisy results, because when you see, say, 70% of observations where the growth is slightly below or slightly above 0, it's not that important for you, but it is very difficult for model to predict these cases correctly. That's why we want to define a slightly less balanced set of classes. So before, there is approximately 50% of cases where growth is below 0% in 1 week, and 50% of cases where growth is more than 0% in a week. But if you define the variable to predict as a growth more than 2%, it is approximately only 20% of cases when this strong growth happened. But the results didn't show the new best growth of a capital, although it's a great addition to the whole system, so that you can try different feature sets, different ML models, and different features to predict, and combine them in various ways and see what combination produces the best results for simulation. Now let's talk about your comments. So comment number 1, thanks for adding more detailed instructions like you do on each question. Thank you for that. I try to add precise instructions that it's easy to follow. And there was a question I have out of topic question. If you're implementing this method in real-time trading, and what is your profit and loss? I did an interview with Alexei about 1 year ago, and I shared my results. So I used these or less advanced, simple simulation methods about 3 years ago, and I got good results when the market was booming, maybe 40% of yearly growth in just 2-3 months. But I didn't have advanced features implemented like risk management and take profit and size of trades that we will discuss today. And at some point my strategy started to lose money and I shut it down. Next comment, more debates and discussions. I'm very happy to read new questions and new ideas on Slack or Telegram. Please add them. Some of you shared the typos that I had in home assignment and on slides, and also there was the first pull request to add community notes for module 3. Thank you for this. Thank you for improving the course content. Please continue doing this, and please send other pull requests for other modules if you have those community notes recorded for other people. Then someone provided a suggestion about the course that if it is possible to consider Dockerization of files, if it is possible to use a secondary platform like Teachable, etc. I discussed this with Alexei, and we use this setup with GitHub, YouTube, and no other platforms because it is quite convenient and it brings organic growth. But if you have some strong suggestions like this and you have experience of working with other platforms, please reach me out in Telegram or Slack, and we can discuss your suggestions for the next course iterations. Then someone said that they learned a lot about decision tree and random forest. The course is quite hard, but it delivers great results for you. That's very great to hear. And someone on Slack, on Slido asked if I'm available for proprietary trading offers. Not yet. I'm not a hedge fund. I don't have a legal structure or legal form. I do not provide these services, but if you're an active trader and you want to see some features or some additional signals that we discussed during the course, please reach me out. I'm planning to build a software as a service solution with subscription fee. For now, I'm thinking about explainability, signals, just for everyone to be easier to understand which features are most important for this or that stock in this or that period of time. But if you think that other features or other signals are important, please let me know. And you will all get the exit survey, so I will ask this question as well. Now let's move to the exploratory question on the ideal strategy components. And most of you got the suggestions that are totally correct, and it's great to implement them. And more than that, I implemented most of the suggestions in the simulation, in the advanced simulation today. So someone said that let's use a threshold when the predicted return is greater than 2%. That's probably a regression model. We didn't cover that, but if you have it in your project, you can use this feature for the simulation and filter out all predictions with the less than 2% predicted return. For all binary models, we predict only probability of a positive growth. Stop loss with the specific numbers, or take profit with the specific numbers. That's great to see that you have those specific numbers in your head, because there are no ideal numbers, or it is quite hard to get. It's more about psychology of a trader, and you need to define these numbers for yourself. Then someone suggested that we can combine predictions to form a new consensus from different models. It's called ensemble learning, and it can be not a random forest, but a set of predictions combined from different models, which produces better results. Then increase or decrease the size of the bet. We are using what is known Kelly's criterion. When the probability of growth is higher, we will have the higher weight for the stock. It can be hundreds of ways of doing this. I use some simple formula, and I will cover it later. Someone said that they are allocating 50% to high frequency trades and 50% of their capital to slower market neutral strategies. This is approximately the same what I'm doing now. So most of my trading is passive investments with slower market neutral strategies, and sometimes I try to do day trading and use the predictions that I get with the system. After stock distributed dividends, so these events are important, and the close price can be different, or it should be different on the dividend size, but adjusted close price should incorporate those dividend payouts. What I've seen in the last year, that not the dividends distribution is important, but the dividends announcement is important. And it's more and more cases when big companies announce their dividends for the first time recently, and these stocks experience huge growth. So then there were some other suggestions. They are all listed here. and it's a food for thought for you when you will be implementing your simulation strategies in your home Capstone project. So now let's move to the advanced strategy simulation. This time we can't have everything defined with the few lines of code for the whole data frame, and we have to iterate over the dates. The main reason for this is capital reinvestment. We will rely on the returns that happen every 5 days from previous investments 1 week ago, and we will reinvest the full capital available for today. We will introduce new features like risk management, top K, which is maximum top K investments per day, size of entry, so bigger investment with a higher probability of growth, and timing, whether you want to buy at open price for the next day, or you want to define some bids for a lower or higher price for the next day, and it can be executed at any time during the next day, but it can be not executed at all. And with this occasion, we will have to leave that capital uninvested, and it will be exactly the same amount of capital transferred for the next week if there are no field bids. But before we go to the new advanced strategy, let's look at the home assignments for question 1. So if you did it correctly, you should have seen this picture. That's we are mostly interested with all predictions with the prefix RF, which is a random forest, and I randomly selected just 2 values during the module 4, which was rule 55, threshold more than 0.55 or 55% probability, and rule 60, which is a 60% probability of growth. And my guess was that if you iterate over other values over thresholds, say between 51 and 60, you will see some better results. And it turned out that it was the right assumption, because you should see a curve like this. That if you have the threshold rule of 51%, you need to do a lot of trades every day, and capital growth is 12%. If you make the threshold rule higher to 52%, 53%, you see less investments, less trades per day, but average growth is higher. And you have a local maximum, which is a decision rule of 53. That is, we need to select all predictions with a predicted probability of growth of more than 53%. We will use this prediction and this model, random forest model, for today's simulation. But what were the problems with this basic strategy? The first and foremost was that capital utilization. If you think about minimum and maximum number of trades for different setups of predictions, we could make around 30 or 33, if you want to be precise, 33 trades per day if we try to buy every single stock. And maximum, it was about 150 trades per day. If you invest $100 or 150 trades per week, sorry. If you invest $100 for each trade, your capital utilization can be between $100 invested and $15,000 invested. So most of the times, especially if you have 5 or 10 trades per day, your capital is not used, which is not good. So if you earn some money, or you earn on average some money from every trade, you need to use all your capital. And we want to do it. We want to do it in this simulation. Then no capital reinvestment. If you compare two options, one is that, say we have 10,000 of initial capital, and every year in 4 years of test setup, you had a 13.6% of growth. So if you sum this growth, because you did not reinvest your capital, you just left aside the new capital you got, you will receive 55% of growth in 4 years. Just 4 multiplied by 13.67%. But if you start reinvesting, that is, if you make more than $100 per each trade, say 110 or 115, you reinvest proportion to the available capital that you have, you can get 60% of growth with reinvestment. That's a big difference within 4 years. And last but not least, and this is the most important assumption, which was not true, that we assume that all bids with adjusted close from the current day can be filled on the next day with the open prices. So our assumption was that if today the trading window is closed, the markets are closed, and we run the system, we got the predictions for the growth for the next week, and we want to buy stocks next day when the markets are open. We assume that we can do it with the prices of adjusted close for the previous day, but it turned out that it's not realistic. Many other market participants, they will see if a stock is actively growing, and they will place higher bids, that you won't be able to execute the trade with the same just close price. You need to bet at a higher price. And last thing, that we most of our strategies, they have many trades per day, 5 to 33 trades per day. The simulation today will show you that actually having many stocks to invest is not always the best solution, and our simulation strategy showed that the better expected return is when you invest only into one maximum prediction every day. So we need to define a few more fields in our data frame just to be able to implement the advanced simulation. And the first field that we want to define is rank for the prediction. And in this case, it's prediction number 14, or it's a predictor with the optimal threshold for a random forest. We are not using those threshold predictions. We will use probability of prediction to define rank, so it's not very different for us if you take prediction 10 or 11 or 14 for ranking, because we use probabilities which are the same for all predictions for a random forest. And if you're interested in learning new features or new methods, just read and try to use this rank function. So we have a data frame with many records. The primary key for the data frame is date and ticker. If you group by date, you have a group object, and you can select the probability of a prediction and rank this probability descending or ascending. So we value more higher probabilities. That's why we are ranking them descending. And that's what you can see if you select the data frame for one date of predictions and filter top 5 predictions. So here are the ranks between 1 and 5, and top prediction was 57%, and bottom prediction was 51%. So if we are filtering out all predictions with a threshold of more than 53%, for that particular day, we would see only 2 stocks that were recommended to trade with the model. This is the full distributions of predictions for the day with 33 stocks in it. And so we have a code snippet number 1. This is the code you have. Define new field, group by date, select one field and rank this field in a descending order. Okay. Next thing that we want to cover is lower entry feature. And originally I assumed that we try to beat at a lower entry at some value that is below 1, at 99% or 98% or lower from the adjusted close price of a previous day, just to be able to get higher revenue if the stock will go up. But you can also define lower entry value higher than 1, say 1.02. That means that you know that in many cases market participants, other market participants will see that those stocks are in a grow mode, and you can sacrifice 2% of your next future profits by betting with a 2% higher price than adjusted close price. So you can create this bid in your trading system just after the market is closed or before market is open, and it will live there for the whole day. So you can define these numbers which are higher than 1, and in this case more of your bets will be executed just because your price is more attractive. But the problem is that less of them, probably less of them, will be profitable because you're buying at a higher price. So those outstanding high-growing stocks are not able to cover the average price that you buy all stocks, which is higher on 2%. For example, let's check this one day, this subset of data frame for particular Apple. For 24th of April, adjusted close was 169, and if you're betting to buy this stock at 100% of this close or at 102% of this close price for the next day, you will be able to do that because next day, the period of a price was between 168 and something. So if you want to be able to simulate the results with this lower entry parameter, you need to define minimum low next one day. That is, we assume that price is continuous, and if the price for the next day went down to some value like 168, we assume that you could buy the stock at all prices and that are higher than 168. So for that particular case, you could fill orders for lower entry equals 1 or 102%, but you won't fill your order at 0.99 at 99%, because 168 is 99.4% from the previous day. So it never went to 99% of price on the next day, and if you created that bit in the trading system, it won't be executed. Then there is another example when the stock was growing and it was growing for several days in a row, and for 26th of April, just the close price was 169, but for the next day, the lowest price was 173. That means that you had to beat, say, 3% more than the close price in order to fill that. So if you had any of these bids, it won't be executed. Let's see how this mean low next one is distributed. So there are many cases in our data frame, and this is not only test, but all test and trained validation data points, about 200k data points. So most of the cases, your next day low is plus minus 2-3% from the adjusted close price for the day before. But sometimes it goes to 50% or 100% above. That means that whole market is crazy about this stock, and they can beat any money, and probably they are losing money in a near future if they beat that high prices from the close, from the adjusted close of the previous day. So you can read this article and understand why does the opening price of a stock differ from the previous day's closing price. There are several cases, and different exchanges and brokers can treat those cases differently. So next step is to define fields for maximum high in the next 5 days and minimum low in the next 5 days. So if you want to have a stop loss condition, that means that, say, if we buy the stock with paying the price 173.5, and we define the stop loss of 2%, this stop loss will be executed for this trade, because during the next 5 days minimum low was 169, which is lower than 2% loss. So if you want to create trades with stop loss, you can limit your maximum loss on one trade. Say you can define 10% of loss, and it will be executed automatically. So we assume that if there is a minimum low price in the next 5 days, which is lower, that's your stop loss criteria, then you will have this trade executed at the price of stop loss. That means that you will lose some money, but you won't go further below. The problem with this approach is that oftentimes markets are volatile, and if you have stop loss of 90 or 10% loss or 0.9 stop loss, you can see that many situations when stop loss is executed are not profitable or are not saving a lot of capital for you, because you're losing 10% on each stop loss case. But if you did not execute that stop loss, the price could go up again, and it could end up of just -5%, so you could lose less money. But psychologically you can hedge against big losses, and you can utilize this thing. And it is recommended to have this condition in all your trades. Just in my simulation, I didn't find that this stop loss feature improves the quality and the overall average growth of capital for the strategy. So next thing is take profit, and this is not very obvious thing to have, but also again because of the high volatility of markets, the end volatility of a stock can be much higher than what you see in the adjusted close price in 5 days. That means that even here for Apple, which is a big stock, big company, and the volatility of a stock in 5 days was approximately 10%. So in 5, if you bought this stock and paid 173, you could end up between 169 and 187, and on average you end up somewhere very close to 173. But you can take profit, say if it is 5% higher from the adjusted cost price, and you can say that let's have an outstanding trade or outstanding bid with take profit of 182 or 5% above adjusted close price, and if this event happened, you take 182, you sell your stock and get 5% of profit minus some fees, but it's a big profit for a week trading. There are some rare events when both events, take profit and stop loss, happened. Say for Apple, for that day, for that week, if you bought stocks and paid 173.5 and it defines two events, take profit for 5% and stop loss for 2%, you could see both of them happen. And within our simulation, we can't understand what happens first. So you need to have hourly data or minute data and have a precise, even more precise simulation. So in these rare events, and these rare events, they will produce a very different financial result for each individual trade, minus 2% of loss or plus 5% of profit in that particular case. But we assume that we can't simulate that properly, and we just make it random 50-50. 50% that take profit happens first, and 50% of stop loss happening first. So Again, here is the distribution of high next 5 days, and what was unexpected, that max high in the next 5 days can be very different from the adjusted close. So it can be 50% higher, or 100% higher, or even 200% higher. So it's an open question. What take profit condition do you want to define? So if you define, say, 100% above adjusted close price take profit condition, it's good to have this, but you won't have it built for the future days. And here is the trade simulation for 1 day algorithm with an advanced simulation. We start from Sunday, and we iterate from the first day to the last day of a simulation period. For us, it's 4 days of a test simulation. We assume that we trade approximately 1/5 of current capital that is available at the current rate. So if it's first 5 days, we take 20% of the initial capital, and they have initial capital of $10,000 in all simulations. So this is $2,000 to invest every day. If we have any positive predictions with predictions that are higher than a threshold. But if it's not the first 5 days, we just sell everything that we invested just 1 week ago, and say we invested 2,000 on the first day, on day number 6, or next week we may have 2010 or 1900 that is left after our simulation, and that is an available capital that we have for that particular day in the future. We after we selected some date and some capital, we find top K predictions. So we generated the ranks for the predictions that are taken from the predicted probabilities of random forest. In this particular setting, I have a simulation parameters with maximum 10 trades per day. So I select top 10 K of predictions maximum, and predictions that are more than 53%. Then I calculate weights. So let's assume that we have a probability of growth of 60% or 0.6, and I use this formula. That's probability of growth minus threshold, which is 0.53, plus 0.01, so that for all trades with that are exactly equal to threshold, we have some positive weight. So in this case, the weight is 0.08. And after we have these weights defined, normally the weights will be something between 0.01 and 0.09, because most of our predictions are slightly higher than 50%. Then you can normalize those weights, just divide them on a sum of all weights, so that total sum of all predictions are more than is exactly 100%. And when you know these normalized weights, you can multiply the investment size, and you will know the exact investment amount. Say one stock can be 1,000, another stock can be 500, and all others can be the remaining 500. If you know the total investment size and current adjusted close price or what's price that you're ready to buy. So you can just define bids with fractional share amounts that total size of a bid will equal to the investment size on each stock. Then when you have those bids defined, you execute, you try to find whether those bids were executed, lower entry. In this case, I'm trying to buy all bids or all stocks on the next day at a 99.5% overprice. And you will see that many of these trades are not executed because it's not enough and you need to price more, to bid more. Then you can also calculate stop loss and take profits. By default, I assume stop loss is 0.9, or I sell automatically if the price goes below of 90%, or I sell automatically if price goes above 120%. Then I calculate financial result for all trades. So here is an example. This is 1 day of predictions, then 10 predictions for these stickers. These are predicted ranks. They are not sorted at this time. So these ranks are between 1 and 10. I also show the actual growth each 5 days and ratios that I calculated to understand whether stop loss, take profit, or lower entry is executed. I also show them here. Then when we know the probability of predictions, we can define weights, which is between 0.01 and 0.09. We normalize this so that stocks have investment share between, say, 5% and 15 or 16% here. And then we try to make bids, and we try to invest 2,000 of dollars on those bids. So we place the bids. That's step number 4. And step number 5, we will see that within 99.5% lower entry parameter, most of our bids are not executed. We have only one bid which is executed. That is, the trade is filled, and the exchange will process your trade. The reason for this is that in many cases you can see that min low next one is more than 1. So you had to bid 3%, 5%, or even 20% higher than adjusted close in order to fill the trade. Then there were no events of stop losses because everything was growing probably, and there was one event of take profit. So this case of stock IDE, if you could bet 90% more than adjusted close price, you could see that at that particular day, at that particular period of time, for the next week, the price was between 13% higher and 30% higher. So your stop loss of 20% would be executed, but your actual profit on that trade would be just less than 1%, even if you're correct with having a lower entry, which is higher than 19.77% above the adjusted close price. So that's the approximate simulation for 1 day. We don't have time to go deeper into the code. Everything is shared in Colab. You can check the code and see how it is implemented. let's see how the simulation is produced for the whole period. So I define the data class, which is called simulation params with these initial params, and intentionally I created stop loss, which is quite low, minus 20% in 5 days, and take profit, which is quite high, plus 30% in 5 days, so that they are not executed often, and top K equals to 5. If you run those simulations, you can see that your bit number was in 4 years of trading, or approximately 1,000 of days of trading, was slightly higher than 3,000, which is average bits per day, 4 bits per day, but field bits was only 553, and it was 16% of field bits. And it's because we are trying to buy at a lower price than the adjusted close, and we try to use the volatility of the next day to fill our bid at a lower price and have a higher profit. And by default, the average growth in 4 years is only 0.29% yearly. That is, you could earn only $117 in 4 years, which is a very small amount. The biggest difference here is because the most profitable trades, which we saw in the approximate strategy, even if it was not fully utilizing capital, but it assumed that all trades are executed, including most profitable trades of 10-20% growth. This time, they are not executed because we are not bidding high enough. So here is a set of experiments, and overall space of optimization or tuning with the different simulation parameters is quite big. So I tried to increase the overall profitability by tuning only one parameter at a time, and probably I ended up in some local maximum, not a global maximum, but still the overall result is much higher. I could achieve average growth of 10%, which is much bigger than 0.29% that we started from. How I did this? So first there were default settings, 5 trades, stop losses and take profit, which are not executed because these numbers are too low or too high, and lower entry at 0.99. It is quite obvious that one of the most important parameters that define your total number of trades and overall financial result is overall price bid that you're ready to pay for the next day bid. And I iterated from 0.97 when I tried to buy all next day stocks with a 3% discount to the price. And if you can guess that the ratio of bids was very small, like 3 or 4% of bids that were executed, and average growth was not good enough, just because most of the capital was not used for trading, and it returned as exactly the same amount in 5 trading days. And I tried to have this lower entry parameter to 3% higher than the adjusted close price. I never tried bidding 5 or 10% higher. I could see that almost everywhere, if I bid 1 to 3% higher, I get negative average growth of capital. This is because when we are successful, the median return in 5 days is only 1 or 2%. That means that if you try to bid higher and try to buy stocks that are in very high demand, you can buy them, but for many other bits, you will be losing money, and overall your overall growth capital will be negative. So when I changed the lower entry, iterated the lower entry between 0.97 and 103%, I found a slightly higher growth rate of 1.48% for a lower entry for 0.99. Then I tried to change the take profit condition, because I saw that there are many cases when the volatility is quite high for the stock, and we want to take maybe not 20%, but 5%, 4%, 2.5%, or 1.5% from the price that we bought, 1.5% higher from the adjusted close price. That means that if we are buying at 1% below adjusted close price, and we are taking profit at 1.5% above adjusted close price, the overall profitability is 2.5%, and this is a very good deal for us. And that's why I could manage to have an average growth rate of 8.6%, which is a good result of a constantly growing capital in 4 years. I tried to make it lower for 1% or 0.5% of take profit, but I found that compound growth rate started to go down. Then when I found that take profit, the optimal take profit is 1.5%, I iterated over stop loss, and I could see that when stop loss trades are executed, they do not actually produce a lot of value for me. They do not increase the growth of a capital, but I could find that I can define a stop loss of 0.86 or minus 14%, and be sure that I do not lose more than 14% of my capital every single day, even though it is not executed or executed only 1, 2, 3 times in 4 years. So I could experimentally find a good defensive threshold for a stop loss. And finally, I did the iteration of over top K, 1, 2, 4, up to 33 stocks. And what was also not very obvious is that top 1 prediction delivered better results, that is 10.39%, so that we don't need to utilize the portfolio optimization theory or combine with the higher investments when we have several stocks. We can use just top 1 prediction, and we will see on the simulation results. So I wouldn't rely very heavily on these just 4 years of simulation, and I would still have different algorithms running for top K equals to 1 or top K equals to more than 1. So in my case, the second best was top K equals to 6, and I could have an average growth of 9.6% of growth. So that's the realistic results of a trading simulation that I could achieve with an advanced features. And this is a capital growth that you could see from 2020, from end of 2020 to June 2024, and that's a small difference of 1% of growth, 9.6 versus 10.6 average capital growth per year could produce a sizable difference of $600 in 4 years. So it's 14.3 versus 14.85 thousand for these two strategies. So that was the advanced simulation. You can use either of these approaches for your projects with the basic simulation or advanced simulation. And if you implement advanced simulation, you will get more points, obviously. So now let's talk about automation. We saw different Colab notebooks, and it's not very convenient to go to the previous session notebooks or save or copy code from the notebooks. So our goal now is to combine everything into one project. And also, I saw that many of you experienced troubles from notebooks that were disconnecting. It's because you are competing on a free tier, you're competing with other users, and compute resources are not guaranteed by Google. And that means that if you're idle, if you're not using your notebook at some moment, you can be disconnected. And that will mean for you that you need to open it again and run this code again. In this setup, I will show you that you can run everything on your local computer. And if your computer is powerful enough, you can run it even much faster than the running time on Google Colab. So, but we won't cover some advanced topics or next topics that we'd like to have, like monitor the system health, how the predictions are deteriorating when you need to retrain the model, or adding some dashboard for visualizing financial results daily. We just want the whole system to download the data, transform it, train the model or use the pre-trained model and make predictions every single day and produce the predictions so that you can place those bets manually. Before I show the screenshot, the Visual Studio Code environment, I want to explain. So here it's not the best example. I combined my previous approach when every folder had only readme.md and Colab a notebook there. So I combined that with the project, with the Python project, with some other set of files which are logically very different. So I advise you to create a separate project and start from scratch and not combine these two different streams together. So if you open the deployment and automation folder, you can see that readme.md now is longer. It has previous links to the slides and YouTube and homework, but also it has some instructions how you can set up the virtual environment, install dependencies, and run the workflow. Then there are several other folders. Scripts folder, I have 3 Python files, and each Python file, data repo, train, and transform, it has a data class defined, logical entity which replicates the whole process of getting data from APIs or getting it from a local storage, then transforming the data or different data sources into one data frame, training the model or loading it from the local storage, and then performing inference. I also have a folder local data, and it has these files. So indexes, data frame, it's a combined set of indexes from Yahoo Finance, macro.df, that's a combined set of features from Fred, data source, and tickers_df, that's a combined source of all 33 stocks. Then on top of it, I have transformed data frame stored in Parquet as well, and random forest model file stored there. So that if I want to rerun the workflow, or if I want to simulate it or adjust it, I can just load some of the files, and I don't need to perform these lengthy operations every single time. But what is important that you add a local data folder to the .gitignore file, so that you do not copy those files to GitHub. Also in that folder I have two main files. One is main.py, that's the executable workflow with the minimal output, that what we want to launch from the terminal, or what we want to launch via regular jobs in Chrome. And second is a system test Jupyter notebook. So in this case, I'll show you that you can run everything locally, but you need to run a local server, and also you can import all files that you define in scripts, or all objects or classes, so that you can have that functionality running in your virtual interactive notebook. So let's check what I have in my Visual Studio Code. So I made it with a bigger font. That's, we see deployment and automation. Let's start from the main.py. That's the main script, and it has just a few lines of code. It is only one function, main. I have some parameters whether I need to fetch all the data, repo, that fetch data from all APIs. Then in this case it's true. If we want to rerun it every day, we need to fetch all new data. I'm fetching data for all dates, but ideally you don't want to overload the API, and you need to implement this incremental fetching, where you combine your existing local data and with only a few days of data that is not covered in the existing local data. Then I perform the transformation of the data. That is, for example, I generate 100 additional data features with all technical indicators from a TLE library, and then I train model, or I retrain it every single time. This is not necessary to do every time, but if you do this, your model will get more and more data and will have the improved quality over time. The problem is that every single day you will have a slightly different model, and you can't rely on the simulation. So we have these parameters. Then first step, I import 3 scripts from my scripts folder, and these are 3 classes: data repository, transform data, and train model. And I initialize data repository. This is just a class with a few fields initialized. If I want to fetch the repository, I run the function fetch, and after I fetch the data internally, I have a data frame defined pandas object. I want to persist this. I want to save this data to the local data folder. If I don't have this fetch report turned on, I just load the data from the local data folder. Next step, actually I can start it running. I I have it here. Virtual environment is already initialized, and I selected the folder 05 deployment and automation, so that if I run this Python file from a terminal, and I have this statement defined, that is, I run only this main function, and that's all for steps. If I run it now, you can see that it starts downloading data, 33 stocks, then indexes, then macro stats, and overall the whole workflow can run in just a few minutes, maybe 2 minutes in my case. The good thing is that when I already, I hide this for now, when I have the data loaded, I do the transformation step. So this is another object, another class, and I send this repository object with all data to the constructor of that class. So I initialize the transformed class with the previous step results. If I want to transform the data, I perform the transformation. That is, I generate all technical indicators, and I join 3 separate data frames of indexes and macro TF into one data frame. And when I have this one transformed TF file, I can save it to the local directory. Or otherwise, I can just load this transformed TF file, and I don't need to do all these operations. If I want to simulate the results, or if I want to play with the data. Then next step is train load the model. We know that from all previous simulations, the optimal model was random forest with 17 levels for maximum depth layers, and with a number of estimators equals to 200. So I implemented this into one function, which is train underscore random underscore forest. So it's implemented there, and I also save the data when it is trained. Or I can just load it from the local repository. And finally, when I have everything initialized, and my class, my object trained, has all the data inside. It has the full DF defined with all feature sets, with all features, and with the model trained. I can make a prediction. So I have this function make underscore inference, and it just runs the prediction for that model on the whole on a whole data frame. So you can access this data frame using dot notation, train.dfu, and I filter out only predictions with rank equals to 1. So we know from the simulation that we might want to train with only one top prediction. And you can see here that the workflow execution is finished, and it printed all the predictions for the last 10 days. So if I was going to trade for the last 10 days, these stocks would be the trades that were predicted by my model. I wouldn't trust the latest prediction here for the day to day, because the trading period is not over. Not all numbers are correct. For example, for adjusted close or macro parameters, they may be not finalized. So if I rerun it in a few hours, I might have different results. But the idea is that I run only one command from a terminal, and it goes through the whole process of downloading data, transformation, training the model, and making predictions. And you can then place trades manually, or implement a Telegram bot to send trades to your phone, or place those trades via a broker API. Also, so this is the simplified version without any output that is not needed. I can test the system in my Jupyter notebook as well. And this is a very useful thing, because you can develop the whole system using these notebooks, and when you have something that is working correctly, you can copy that to the scripts files, and then continue experiments. In order to run this notebook, you need to have a Jupyter extension installed in the VS Code, and you also need to run the Jupyter server. So how do I do this? I can open a new terminal window. I can activate my virtual environment, and when I have this virtual environment activated, now I can start a new server with the command Jupyter notebook. So you need to have that dependencies, like all libraries needed for a starting server, installed in your virtual environment, and you need to run code pip install requirements.txt. So I have those all those requirements listed in the requirements.txt. So if you do this, you will be able to run the workflow and run the server locally. So now I have the address for the local host. So you can run that notebook either from the UI. Oftentimes it creates it opens a window in a browser, but in my case I like running it from the Visual Studio Code, so I need to join to attach this file to another Jupyter server, and I copy the local host with the token so that it can connect to that kernel. And now when it is connected, I can clear all outputs, even restart the server if I need it, or run all. And now when you run everything, okay, it doesn't see my my scripts folder. The problem is that I started this from the wrong folder. So let's have let's init the environment and start the notebook now from this folder. I have another server running on another port. Of course, it's better to kill all the servers before you start in another. So, but let's try if I can make it working. So let me clear all outputs and run all. So as you can see, that's approximately the same code where I import classes and make some operations, but now I have some additional commands or checks or even graphs that I can see and develop from the Visual Studio Code. So that's the simple or that's the expected version of a project that you might have as a result of your Capstone project work. And now let's discuss what are the project criteria. So I don't have any other data slides. The recap for the session today, we checked everything that was covered in home assignment number 4. We spent some time discussing advanced simulation, and I showed you how to do the automation to have a local development in Visual Studio Code, run Jupyter notebooks locally, move all results from Colab to Python files, and create data classes, and also how to run a workflow from terminal or from a Jupyter notebook. Now let's talk about the project. You won't have the home assignments for this week. There are too many people who are not submitting home assignments every next week, so I've decided to skip homework for this week just to give you more time for the Capstone project development. The Capstone project criteria, they are already shared 1 week or several weeks ago. There is a README file. The deadline will be 2 weeks after the project submission is available. It is still not available. I plan to do it later this week. So when I make it available, I will send a message on Telegram and Slack. And general timeline is 2 weeks for the project development and 1 week for a peer review. So what are the project criteria? You can see here the README file, the deliverables. It depends on your project, but approximately it's the same set of deliverables that I showed today, or that you can see from the 05 deployment and automation folder. We ask you to do the peer review. So if you don't do peer reviewing, you won't get the certificate. It is an important step of the process. So please do, and please leave the comments. Evaluation criteria. So there are several clusters of evaluation criteria. And the logic is that you can get the final score somewhere between 6 and approximately 30 points. I don't expect you to get maximum points for all for your project. Probably you will go deeper into some area of investing or ML modeling or simulations or anything else. But I do expect you to implement the minimum quality criteria for each step. So you can't just download data from different APIs and tell me that it's your final project. You need to implement every step of a project with a minimum scope. A minimum scope for a problem description is to describe in with me what is your project about, what are the steps, what are the strategies, and what are the final results. So if you do more and more description on your learnings, on different strategies, on every step, and how to reproduce it easily, you will get more points. And every single cluster of criteria, it has this this one field, which is a new problem definition or new models training. So if you introduce to the course something new which we did not cover before, it's great to see. So I encourage you to try new things which we did not try before. So for the data sources piece, the easiest thing is to use data sources and features from the lectures. But if you think more about those features, you can define, say, 10% of new features and 20 plus new features. Hopefully it will be not just a lot of new dummies that are not very meaningful for your estimation, but you can think about new derived features. Or you can use some new data source for your model. I specifically value projects with a large data set with 1 million of records. Your ML models will work better if you have it, but all steps for transformations and model training will be slower. So I advise you to have a small data set to do everything on it, and then when you have everything defined on the best model and best everything, just use a large data set. Then data transformations and exploratory data analysis. If you just combine everything into one data frame and define features as we did in lectures, you get 1 point, but you can do more. Modeling, by default, I assume that you will use decision tree and random forest, at least 2 ML models. But also you can use neural networks or train a regression model, XGBoost or other models, just to get more points. And specifically hyperparameters optimization and decision rules are quite important as well. So it's not only model types, but how you initialize your models and what parameters do you use for that. Then trading simulation, it's if you have vector simulation for at least one strategy, it's already a good result. If you have simulations for several strategies, you get more data points. And automation, that's if you can replicate the same workflow in a Python file, and you can launch it with one command. That's the final state of your project. We have bonus points up to 7 points. So I selected some bonus points, and they are subjective. They are on peer reviewers. So please try to comment your code, to design it properly. Try to add additional functionalities. Say use some API to place the bets, or implement monitoring of the model's quality, or create cloud deployment of containerization. Or it can be something else that is not listed in this set of criteria, but a peer reviewer can mention them and grant you additional data points. So that's it for today. Thanks, folks, for listening. And wait for the next announcement, but in the meantime, you have a few more days to start working on your projects. After I prepare everything for projects to be submitted, and the deadline for 2 weeks will be announced as well. Have a great week ahead and see you next time. Bye bye.